Then you'd calculate pooled variance, and again they give you sum of squares, so hopefully you still have that equation and you can just figure that out. And then they want estimated standard error, which again is the bottom half of that t-square equation I gave you. So once you calculate those two things, you can multiply the estimated standard error times your t-critical point to find your plus or minus SMD. And once you find that, you add and subtract it to your estimation. So 11 plus TSMD and 11 minus TSMD to find your confidence interval. I will tell you that I got decimals in my numbers. Like, it lets you go out to it lets you go out 2 decimals points past the decimal point. So I have pretty much been using decimals in all of these. I hope that didn't confuse you. If that confused you, ignore what I just said because it's not important for the homework. So on to the third one. You are now doing, nope, you're still doing independent measure, which is great because independent measure tests are they're just phenomenal. So you have n equals 18 for both of them, and you don't even worry about it because you just want to subtract the means from each other to figure out your estimated population mean difference. So you subtract 86.4 minus 78.8, and you get your estimated mean difference, which is great. And then you add your n's and subtract 2 to find your degrees of freedom. I think, oh yeah, this is 3. Yeah, I used a two-tailed test on this one too. I don't know, it does say that it's increasing like your performance, so it might be one-tailed. Again, I'll ask Chris. So whether you use a one-tailed or a two-tailed, you're still going to have, well, if you're using two-tailed and they want 90%, you'd use the degrees of freedom, or you'd still have the same degrees of freedom, but your alpha would still be the same. It'd still be 0.1. But if you're doing two-tailed, you want 0.05 in each tail. And if you're doing one-tailed, you just have 0.01, the 0.1 in the one tail. So, you know, once you calculate your t-critical, you can find pooled variance because, again, they give you sum of squares, which is great. These people obviously are being nice to us this time. And then you want to calculate your standard error, bottom half of the t equation. So your pooled variance over your n. And remember that it's pooled variance over n1 plus pooled variance over n2 because your n's are different this time, so it actually makes a difference. And remember that you want to add the fractions before you take the square root of them because, yeah, you just don't want to take the square root of both and then add them together. It doesn't work. You'll get a weird answer, or just a wrong answer. It's not that weird. And then, once you calculate your standard error, you multiply it by your t-critical point to find plus or minus TSMD. And then you add and subtract that from your estimated difference. And that is the answer. Oh, I wrote it in wrong. I'll fix. Yeah, I'll just fix it right now. No, it's no problem. Don't even worry about it, Ben. We're all just waiting for you to tell me how to do the homework. But what's really great is that it is all the same. So once you guys become masters of this, you won't even have to worry about the test on Wednesday because you'll just be so prepared. All right. And then number 4, this time you have, oh, great, a repeated measures test. And remember, a repeated measure test means you have the same sample of people, you just do 2 different things. Like you have 2 different conditions or something. Yeah. So anyway, they give you the mean difference, which is funny because they want you to estimate the mean the mean difference of the population. And when you're estimating, you just assume that your sample is the same as a population. So you say that the mean difference is the mean difference of the population. Huh, how cool is that? So you don't even have to do math right there. I think I used a one-tailed test on this one. Yeah, I did. So anyway, I used a one-tailed test. You can use a two-tailed test. It does make a difference, so that's why I need to ask Coke, like, which one's right. But for now, do whatever makes you happy. If you see they want 90% confidence interval, which, as we all know now, is 0.1 as your alpha. So that's great. You do that. You adjust your degrees of freedom to your n-1 in this case, because there's only one sample. And then you write down your t-score, or your t-critical, not your t-score. And then you estimate your standard error, which is slightly different, not really that different. In this case, standard error, which I guess is SM, equals the square root of s squared over n. Yep. So this is that one right there. S squared over the square root of m. The square root of s squared over n. And that will calculate your standard difference. Or standard error, not standard difference. Which you will need to know your variance, but since they give you standard deviation, you just square that number, and then you divide it by your n and take the square root of that answer, and that is your estimated standard error. So then you multiply your estimated standard error times your t-critical to find plus or minus TSM, and then you add and subtract it from your estimated mean difference. So in this case, 6.8. I'm gonna tell you the answer this time because you already have it. Cool. Thanks for helping with telling the answers. I told myself I wasn't gonna tell answers so you guys couldn't just like skip around and just like write down all the answers, because I could get in trouble for that. Maybe. Probably no one's gonna watch this, so it's not that big of a deal. So the last one, we've already made it to the last one. Isn't this great? The last one gives you a sample of n equals 16, and your mean difference is 21 points, and your sum of squares is 1,215. They want an estimate. Whoa! They gave it to you right there. MD equals 21. Now they want to know 80% confidence interval. All of a sudden, they're not asking you to find anything, but you still have to find it. So you need to find your variance, s squared. So that is just, you know, the sum of squares divided by n-1 in this case, because there's nothing to add it to. It's just 1,215 divided by the 15. It's just how you find it. So once you find variance, you plug that into the equation that we just used, the square root of variance over sample size, or better known as s squared over n, and then that'll calculate your standard error. And once you have standard error, you multiply that times your t-critical point, which we haven't found because I didn't tell you how to do that. It's great because we get to use the table. Yay! I used the two-tailed test just because it was easier. You can use whatever you want. The alpha score is 0.2 because 0.2 times 100 is 80. Well, actually, it's 20, but then you have that 80%, so that's 80%. Anyway, that's your alpha score is 0.2. So then you go on the table, you'd go down to the degrees of freedom, which would be 15, and you would just go down the column and choose 0.2 in either a two-tailed or a one-tailed, and that would be your t-critical. Then you'd multiply your t-critical times the standard error that you've just found, and then that's your plus or minus, you know, TSMD or whatever you want to call it, and then you add and subtract that from 21, which is your point estimate. And then all of a sudden, you're done. Good work. And if you have any questions, feel free to just ask me on Facebook, because I think we're all Facebook friends. And if not, that's great. I'm glad you figured it out. So yeah. Good job, guys.